Dask has a number of best practices to keep in mind. The first rule of Dask is don't use Dask. If you can reduce your data down or make some kind of sampling from it, using other libraries like pandas or Numpy is a much better way to go. The next tip is to use the Dask Dashboard. It's incredibly helpful to see what's going on and is really useful for identifying areas of inefficiency. With Dask computations themselves, you want to avoid very large partitions or chunks, and similarly, you want to avoid having very large task graphs with an excessive number of nodes. It's also really important to be storing large data in a smart way on disk. It'll really affect how easily you can access it. For data frames, we recommend Parquet. For arrays, we recommend Zar. Now the big one is that you want to call delayed on the function itself, not the result that's returned from the function. If you try and delay the result by mistake, the function is going to run immediately before we reach the delay, and that's the opposite of what we want. You want to break up delayed computations, not bundle it all into just one. Now the reason for that is every delayed call becomes one node in the Dask task graph. So if you want any advantage from parallelization, you have to have more than one so they can be sent off to different workers simultaneously. And on the flip side of that, you also don't want too many delayed calls, because that's bad too. Now, you never want to call delayed from within another delayed function. This is a recipe for confusion, especially confusing error messages. Finally, you also shouldn't call delayed on collections like Dask arrays or Dask data frames. And that's because collections in Dask are already optimized for that purpose, so you'll probably just wind up slowing things down. Today we've gone on a tour to see how Dask is used under the hood in a range of different scientific computing libraries. We've seen examples from statistical genetics, single-cell analysis and spatial omics, right through to microscopy, visualization and image analysis. I've also given you some starting points for how you might go about integrating Dask into your own code. I hope that it's helpful for you if you're thinking about getting stuck in and experimenting. I'm always happy to answer questions, and you can find me anytime on Twitter and on the Dask Slack channel.